Hello and welcome to the world of NDE 4.0 and to the world of digital transformation. Now today we will not be speaking that much about NDE. I will focus more on digital transformation. Because that is something I found out during our journey towards NDE 4.0, towards digital transformation. If you have about 5,000 people, you have about 10,000 different opinions on digital transformation. And I hope today that perhaps we here in this room, we can converge on one opinion. And we have been working very actively during the last 5 years on coming up with a model on how to really explain, visualize digital transformation and NDE 4.0. And that's the main focus of my talk today. Now, at some points, it might seem that this becomes kind of that's a difficult English word, philosophical, or quite visionary. But there is a lot more depth to it, and today I would like to stay here on this philosophical, visionary level. But before I get into what is really digital transformation and how we differentiate digital transformation from digitization and digitalization, let me show you a little bit my way towards the world of digital transformation. And it all started when I was a kid. I was always really into technology. And this was my 8th birthday, and you can see how happy I was on that day. And that was the reason. I got this analog keyboard for my birthday. I still have it, I still use it. Actually, currently it's stowed away because we're renovating our house, but that's a different story. But this interest in technology led to me studying physics, into me getting into quantum optics and quantum computers. That was my master thesis. And what we did back in those days is we worked on the entanglement, on the quantum mechanical entanglement between a single photon and a single atom. If you really look closely, you will see that single atom right behind me. Now, what does this experiment have to do with anything we are dealing with? Now, this comes back to quantum computers. If you want to have 2 quantum computers and you want those 2 quantum computers to work together on one problem, you will have to have a communication channel between the 2 of them. And not just a classical communication channel like we're used to having it. No, you need a quantum communication channel. And to get that, you need entanglement between those 2 quantum computers. And you can do that by entangling one with a photon, by entangling another one with a photon, measuring those 2 photons, and then suddenly those 2 quantum computers become entangled. Even if one is situated here in LA and the other one in Singapore. And they will start working together. That's the power of quantum mechanics. Now, already back then I was really fascinated by this topic, and originally I wanted to get into semiconductor physics. I was really fascinated by that topic. Then I learned about quantum computers and I forgot everything else in the past. But what I learned during doing this work is it will be at least 20 more years until those things become reality. I wanted to do something more hands-on. So that's how I got into nondestructive testing. And I started doing work on induction thermography. That was my PhD. And after my PhD, my employer threw me into ultrasonic testing. So I had to become an expert in ultrasonic testing. We worked on the development of a lot of new methods, for example, quantitative synthetic aperture focusing techniques, or kind of a computed ultrasonic tomography for ultrasonic data, which is now applied at various forging vendors around the globe in serial production. But during that time, there was also one project. And that project was about, I was approached by our fraction mechanics specialists because they wanted to know more about the components they were doing the fraction mechanics on. And so they were thinking of, can NDE give them that knowledge they need? So yes, we can. And what we did is we started to build up a database, a large database, to have all the NDE results. We also included all the material testing, so all the destructive testing in it. And we started statistically analyzing it. And with that knowledge we created out of it, we were actually able to calculate the lifetime of those components way more accurately, without changing anything on the product, without changing anything on how you design it. It was still the same design, just by analyzing the data. And the more exact knowledge, the more exact calculation of the lifetime, it was going from a lifetime of about 6 years, until you had to do this first service, to about 12 years to do the first service. And can you imagine what the business case for that one was? That was the point where I saw there is way more value to NDE and to sensors than what we currently believe it is. That was the start of me getting into NDE 4.0. So somewhere in 2017, then also others started with the idea of NDE 4.0. I was not the one coming up with the name, that was Norbert. And in 2017, Norbert did a presentation here at this symposium on NDE 4.0. And I was one of the founding members of the German Society, or on the NDE 4.0 group in the German Society. And then later on, I proposed to ASNT, should we also be doing an NDE 4.0 session at the annual conference? I think back then it was back in Houston. And they said, yes, we can do that. But we have a second gentleman who wants to do the exact same thing. And that's this gentleman, Ripi Singh, who is the co-author also of this presentation and of most of the publications I've written in the last 5 years. And when we met for the first time in Houston, we went for a happy hour for some beers, and we started discussing. And we saw that we had very controversial opinions on about everything. So the word we used most oftenly was no. But we converted. We came to one conclusion. So that's how this became such a fruitful collaboration between the two of us. It led to the two of us writing this book, The World of NDE 4.0, which is actually available not only by ASNT. ASNT is the publisher of this book, but now also through SPIE. And you can buy it upstairs. And actually the price here at this conference from SPIE is cheaper than what ASNT is taking for it. So get it now. No, after Nesrin, so. And it also led to the two of us giving a lot of workshops on NDE 4.0, a digital transformation, and you can see us at one of our customers. So, now, coming to the main topic of this presentation. Digital transformation. But before I get into the digital transformation, let us have a look into the industrialized society. So our society, we have our ecosystem. Within our ecosystem, we have governance, we have companies, which includes research institutes and nonprofit organizations, and we have the consumer groups. Within a company, you will find policies, you will find processes, you will find leadership. And so that we can actually work on those processes, we need procedures, we need equipment, and we need people. So this is a very simplified model of our industrialized society. And that model was kind of, or this is how our societies worked somewhere during the first, second industrial revolution. Now, when the third industrial revolution kicked in, the third revolution was all about digitizing. And what digitizing just means is we convert our analog media to something digital. Whether it's a sheet of paper, whether it's a tape, or whether it is something else. We convert all of it into the same zeros and ones. Now we still have different media to actually carry those zeros and ones. It can be a floppy disk, it can be a CD, it can be a hard drive or a USB stick or a cloud. But in essence, it's always the same zeros and ones, which makes it so handy to copy it from one machine to the next to the next. So that's kind of what happened during the third revolution, was digitize. Soon after, now that we have the data in a digitized form, we can start to digitalize. We can use digital technologies to simplify isolated tasks, isolated processes. So this can be, if you open your word processor, it can be a simple search and replace. This makes your life a lot easier. This simplifies an isolated process you want to do. This can also be an Excel sheet you're creating to make your life easier. This can also be an ERP system. Now I know that some of the ERP systems seem to make more work than they are actually taking away, but in essence they are doing a good job. They helped us a lot. It could also be the use of ChatGPT to write an essay. ChatGPT and all the other artificial intelligence solutions are kind of all digitalization solutions. Can also be a workflow management system for non-destructive testing. But now we are coming to the third topic, and that's digital transformation. Now it's nice to have all those tools to really simplify isolated tasks. That's really good. What would we do without them? But how about that the information I calculated in that Excel sheet is actually going into the ERP system, then the ERP system is doing something with it, combining the data with something else, and then finally taking automatically some action. So what we need to do, we have to integrate all of those digitalization solutions so that the companies can have a better value for themselves, better business. And that is digitally transform. Now you can already see, around here, digitize. We needed some basic infrastructure. That basic infrastructure was more or less how to encode data into a digital format. Digitalize, we need a little bit more of infrastructure. We needed operating systems. We needed software development tools. We needed AI platforms to do all of that. But now we are coming to digitally transform. And this is the topic where we are really talking about infrastructure. Because now we need an architecture which helps actually our systems to talk to each other automatically without us having to do all the nitty-bitty greedy things of doing the programming. Because if you think about a large OEM, how many digitalization solutions will an employer with 100,000 employees have? Most likely 500,000. And if you think about you want to integrate all of them, 500,000 times 500,000, that's about the amount of interfaces you need. Nobody could do that ever. So we need to automate this process of creating those interfaces to actually have all of the systems grow together. Now what you can already see on this model is there's one more step. There's one more step towards the ecosystem, where governance, companies, and consumers are digitally connected. But that's not the topic of today's presentation. Okay, now where does this fall into our industrialized, or in our revolutions, in our industry 1, 2, 3, 4? Now, one thing I should be mentioning is, before we had the first revolution, for sure we were producing something. We were using handcraft. We were also doing NDE. We did human perception. Then we come into mechanization, we came into a technical revolution, where we use all the analog things, where we had all the X-ray and ultrasonics, which expanded our human senses to areas where usually we cannot grasp anything. We came to a digital revolution. And here can you already see, okay, this is the digital revolution. So this is where Digitize started. And right soon after, Digitalized started. But Digitalize is still going on. There is more and more digitalization solutions coming up, and it will continue during the next decades. So for me, Digitize, that was the third revolution. Digitalize, we are already on the way to the fourth revolution. And now we're coming to the third revolution, where we're getting into this interconnected cyber-physical. And this is where we are getting into the digital transformation. So now we are really at the fourth revolution. Now let's have a look into reality. Let's have a look into why we are doing NDE. Who knows what has happened to this building? That's so-called AquaDom in Berlin. It's a huge aquarium within a hotel, within the lobby of a hotel. And you can actually take the elevator and go through it. It has about 900 square cubic meters of water and about 1,500 fish living in that aquarium. Yeah, you will not be able to see that anymore. And they will not be going to reconstruct this one, most likely. This was in December 2022. We had a rupture of this tank. Luckily, it was somewhere 4 or 5 o'clock in the morning, so nobody was in the lobby. There was a Christmas tree standing in that lobby. That Christmas tree was never found. The hotel, I don't think they can reuse that hotel. The attached shopping mall to the hotel, I don't think they can use that attached shopping mall. That's why we need sensors. That's why we need NDE. We have to prevent this from happening. And this is also why we need POD. Now, I don't know why this has happened. I don't know if they have done any NDE on it. But my guess is some inspections were done on this component. But I bet nobody has looked into the reliability of those inspections for this component. Especially not for having it run from 2003 to 2022. That's nearly 20 years of operation. I don't think they did some structural health monitoring it. I bet they had some automation solutions to turn on the lighting and stuff like that. Yeah. And that is the reason we have to look for the reliability. We have to know the reliability of our physical sensing mechanisms. And once we come to digitization, the story doesn't change. We need reliability assessments of all the digitalized sensing mechanisms. No matter whether it's NDE or it's structural health monitoring or it's some sensor. Now with the digitalization, the story is even becoming more interesting. Because now we want to use an AI solution to enhance our results. But we have to prove, are the results becoming better? Or even worse? We want to use perhaps a blockchain to make sure that nobody really changes our results we have accomplished. We have to prove the reliability of those tools. We want to use a quantum computer. Yeah, we have to prove that the quantum computer is doing a better job than what we did before. So, if we want to sell the digitalization of perception, we will need reliability tools so that our customers believe us that they are buying something good. So for me, reliability was important. It's now becoming essential to assess those solutions. But we have one additional step here. So how is reliability attached to digital transformation? So let's get a little bit into our visions of NDE 4.0. And so if we look at a typical feedback loop, which I guess most of us have been doing during their PhD or during their research. We have some data source, we do some data processing, we create some knowledge out of it, and we create some action out of it. We're done with our PhD, we write our thesis, we hand it over. And somebody comes to the idea, oh, this is working. So we start adding more data sources. We're adding more processing, more data sources, a fancy augmented reality so that we can sell it to management. Perhaps even an AI solution on top of that. And at some point, we're getting here. Because this solution is not transferable. It is not scalable. It was never meant to be that way. And also, if I think about current day PhD thesis works, back in the days, we were really working on the sensors. But now it is more and more coming here to this point of data processing and knowledge creation and automatic feedback loops. So those poor guys have to do a lot of work for the data capture and kind of not really focus on the data processing. That's where they have to focus on. So we need something to help them going forward and to help everything going forward. Now, a couple of key steps I currently see getting there. Number one is the creation of an Internet of Things. So that about every system can talk to about every other system, so the basis for digital transformation, and so that we can fuse all sorts of data sources automatically. But what do we need for that? We need to give the data structure, we have to make the data machine readable, we have to convert the data to information. So how to do that? Now on the next slide, I will show you one piece of data, one number. And I bet at least half of you will immediately know what this information is about. So you will be able to convert that piece of data to information immediately. I hear some laughing, so at least one person got it. But if you enter the number 42 into a computer, the computer will have no clue about it. If I have a good programming, then that good programming could actually start searching the internet. It will find Wikipedia, and the number 42, it has about 107 different meanings. If I ask ChatGPT, it's actually giving me the answer I'm looking for, but that's a different story. But that information could also be my weight in kilograms. But then comes the question, what year was that? Or the length of a truck, 42nd day of a year, gain of a UT instrument. But then comes the question, was that before or after calibration? At which day, which probe, which component? So we need to answer we have to add to that one piece of data. We have to add all of the surrounding information so that the computer knows what this piece of data is about. And once we do that, we turn that piece of data to information. We need all of the metadata to create from that piece of data some information. And the way of doing that is called semantic interoperability. And what we have to create for that is we have to create ontologies. And once we do that, that a computer will know that this is actually the answer to the ultimate question of life, universe, and everything, at least to Douglas Adams' book, Hitchhiker's Guide to the Galaxy. So, we have the IoT, we are fusing the data using semantic interoperability, we are creating information out of it. Now we are coming to data processing, which is usually proprietary. But in my eyes, we should go here towards a digital twin. Now, same thing is true for digital twins and what is said for digital transformation. If you ask 5,000 people, you will get 10,000 opinions. In my world, a digital twin is kind of an architecture, an open architecture, where you can have all sorts of data interfaces, kind of plug and play for data processing modules, plug and play for visualization and action, so that we can actually get into the cyber-physical loop closing. Now, if we look into the cyber-physical loop, there are a couple of key technology fields we see in here. One is here the information technologies, IT. One is all the operational technologies. And usually people, if they talk about Industry 4.0 and digital transformation, they talk only about IT and OT. But for me, there's a third one. Perception technologies. So we are going from perception to information technologies to operational technologies. And here, this is our physical world, where we are closing that loop. Now let's have a look into what we as humans do. We have our sensors. And it's not just 5, we have about 20 of them. We're giving it to our brain or our nerves. And then we have the feedback to our operational technologies. And who would have the human perception integrated into our legs and arms? Nobody would do that as a human. But somehow people do that they put operational technologies and perception into one. I don't know why. Perhaps someday somebody can explain me. Now, taking you a little bit further, and this is now something I have created very recently, so there might still be some tweaking necessary on that one. But why do humans need perception? Humans want to learn, or need to learn. We have standard operating conditions, we have exceptional operating conditions. Let's say a truck is suddenly appearing over here. We have to do something. I have to act towards some external thing happening. And with different sensors, with external sensors, which help us learning, training our neural nets. They help us walking, interacting, giving this course, giving this lecture. Keeping my brain from being bored. Staying safe. Reacting quick to sudden changes. With internal sensors. For training our neural net. For monitoring our physical health automatically. Our body is doing a lot of monitoring automatically. And also here, oh, something is hurting my leg. Perhaps I shouldn't be walking that quickly anymore. My body automatically restricts my movement. And there are virtual sensors. That's at least how I call them. Dreaming. It's kind of a virtual sensor which helps me learning and also helps on my standard operating conditions. It also helps me keep my brain from being bored. And this is where also what we call sixth sense, where this one is coming into the game. Now why I'm discussing here the human needs for perception is because now we can see, okay, how can we transfer this over to systems? So in essence, humans need all the perception so that we can live safely, healthy, and keep our brains from being bored. So how does this transfer over to systems? Again, we have standard operating conditions. So we need some external sensors, something for the environmental conditions, for other stuff. We need internal sensors like condition monitoring and also put NDE into it. Because NDE, in essence, it is giving us information from the internal structure, not from the external world. That's why they are within the internal. We need something for exceptional operating conditions, like the tank exploding. perhaps there should have been a sensor detecting something is going on with that tank about 2 days early, so that they can already evacuate that hotel or just pump the water out of it. We can also get into learning once we get into AIs. And virtual, some of that can be seen as quite visionary, or I don't know. But perhaps some of that could become reality in the future. So in essence, we need the perception for our systems so that our systems can operate safely, stay healthy, and keep its AI from being bored. So, coming back to digital transformation and to our cyber-physical loops, because this is in essence what we need to do for what we do with digital transformation. We are all using digital or cyber-physical loops. Some of them small, some of them a lot bigger. And if we want to use the data from perception within the information technologies to do something with our operational technologies, we need to know the reliability. So we started with reliability is good because we know how reliable is that data, or how reliable is that inspection method. Can we find what we are supposed to find? It becomes commercially interesting for all the digitalization solutions. But once we come to digitally transform, in my eyes, this is one of the key enablers. This is where all of this is getting critical. So, a little bit about more information. There is the handbook of NDE 4.0. That one is about 1,400 pages of content. The price is a little bit high. It costs about 800 euros or $800. So if you want to read something, either you write a chapter, or either you go to a library, that's the first step, and get them to buy it for you. Or you buy the individual chapters, or we just now are starting to write the second edition for that handbook. And if you contribute a paper or a chapter to that handbook, you will get free access to all the others. So if you have an idea, approach me or Norbert, and we'll be happy to discuss your ideas and how to integrate that into the book. And we have the World of NDE 4.0, which we already discussed in the beginning, and which you can buy up there at the SPIE lobby. And then there is a third book, which is called How to Embrace NDE 4.0, which is written by Ripi and Ramon. On this one, I just wrote the foreword. And this is really about how to create a roadmap for NDE 4.0. So you will have to get into this one first before you get into this one. And this one is available through Amazon. It's self-published. We've written a couple of peer-reviewed publications, like going into the basic with the NDE 4.0, a design thinking perspective, technical deep dive here into industrial Internet of Things, digital twins, and cyber-physical loops. Here we're getting into really what's the value of all the data, what's the value of NDE 4.0. We have a chapter of the handbook on digitization, digitalization, digital transformation. We have article from the Japanese Society for Nondestructive Testing, where we are talking on the one side again about digitization, so all what I talked about today is in that paper, but we also took that one step further into some success stories. And then here, this is published by the Canadian Institute. This is about how to create a roadmap for NDE 4.0. There is an NDE 4.0 YouTube channel where I was trying to do one video a week. Currently, it's about one video every second month or every third month. It's just, with Corona allowing me to travel, there is no more point in, or there is no more time for doing videos. But you will find a lot of information on this one. There are about 30 videos about NDE 4.0 and digital transformation. There are 12 videos about ultrasonic testing, getting into some of the details. So it might be worth a look onto that channel. That's how easy it is. So thank you for your attention. You now have about 5 minutes to scan the QR code to get in contact with me. And the room is open for questions.